According to the National Electrical Code, there is no specific requirement for a disconnecting means near or at a resistive load bank. Similarly, there is no specific requirement in the National Electrical Code for a disconnecting means near or at an inductive load bank. If a disconnecting means is required for any reason, for example, maintenance or emergency shutdown, the National Electrical Code does not specify a maximum distance from the load bank. A fuse block can be used as a disconnecting means if it meets the following criteria. Firstly, it must be rated for the full load current of the load bank. Secondly, it must be installed in a readily accessible location. And thirdly, it must be labeled as a disconnecting means. NFPA 70E, electrical safety in the workplace, may require a disconnecting means if the load bank poses a risk to workers during maintenance or emergency situations. Some local codes may have specific requirements for disconnecting means for load banks. Based on the National Electrical Code, a disconnecting means is not generally required for resistive or inductive load banks. However, a disconnecting means may be required based on other codes, standards, or specific site conditions. A fuse block can be used as a disconnecting means if it meets the above criteria. The specific requirements and distance should be determined based on the applicable codes, standards, and site-specific needs. To delve deeper into the subject of electrical safety and compliance, let's further expand upon these core concepts. We will look into the nuances of load banks, disconnecting means, and the pertinent codes and standards that govern their application. Load banks are essential tools used for testing electrical power systems under simulated load conditions. These devices come in primarily two forms: resistive and inductive, each serving a distinct purpose. Resistive load banks, as the name implies, utilize resistors to dissipate electrical energy as heat. They are employed to simulate the behavior of electrical devices that consume power and generate heat, such as lighting systems, heaters, and other appliances. Inductive load banks, on the other hand, employ inductors to create a lagging power factor load. These are used to simulate the operational characteristics of equipment like motors, transformers, and other inductive components commonly found in industrial settings. A disconnecting means is a crucial safety component in any electrical system. It serves as a switch or circuit breaker that can isolate a load or piece of equipment from its power source. This isolation is essential for performing maintenance, troubleshooting issues, or ensuring safety during emergency situations. The disconnecting means must be readily accessible and clearly labeled to enable quick and safe operation. The National Electrical Code, or NEC, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment in the United States. While the NEC does not explicitly mandate a disconnecting means for all load bank installations, it provides general guidelines and requirements that may indirectly apply. For instance, the NEC requires disconnecting means for certain types of equipment to facilitate safe maintenance and repairs. If a load bank is considered part of such equipment, or if its operation poses a significant electrical hazard, a disconnecting means may be necessary. NFPA 70E, electrical safety in the workplace, is another crucial standard that addresses electrical safety requirements for employees. This standard focuses on protecting workers from electrical hazards such as shock, arc flash, and arc blast. NFPA 70E may require a disconnecting means for a load bank if its operation or maintenance exposes workers to electrical risks. The need for a disconnecting means in such cases depends on a thorough risk assessment and the implementation of appropriate safety measures. Fuse blocks, consisting of fuses and fuse holders, are commonly used as disconnecting means in electrical circuits. A fuse is an overcurrent protection device that contains a fusible link, which melts and interrupts the circuit when the current exceeds a predetermined value. A fuse block provides a convenient way to house and access fuses, making them suitable for use as disconnecting means in certain applications. For a fuse block to be considered an acceptable disconnecting means, it must meet several critical criteria. Firstly, the fuse block must be rated for the full load current of the load bank. This means that the fuse block and its fuses must be capable of safely handling the maximum current that the load bank is designed to draw. Overrating the fuse block is essential to prevent nuisance tripping and ensure reliable operation. Secondly, the fuse block must be installed in a readily accessible location. This requirement ensures that workers can quickly and easily access the fuse block to disconnect the load bank in case of emergency or maintenance. The location should be free from obstructions and clearly marked for easy identification. Thirdly, the fuse block must be clearly labeled as a disconnecting means. This labeling informs workers and others that the fuse block can be used to disconnect the load bank from its power source. The label should be durable and easy to read even in dimly lit environments. In addition to these criteria, the fuse block must also comply with other applicable requirements of the National Electrical Code and other relevant standards. This may include requirements for enclosure type, wiring methods, and grounding. Local electrical codes may also have specific requirements for disconnecting means, so it is essential to consult with local authorities to ensure compliance. The distance between the disconnecting means and the load bank is another important consideration. While the National Electrical Code does not specify a maximum distance, it is generally recommended to locate the disconnecting means as close as possible to the load bank. This proximity minimizes the amount of exposed energized conductors and reduces the risk of electrical hazards. In situations where the disconnecting means cannot be located near the load bank, additional safety measures may be necessary. These measures may include the use of insulated conductors, conduit, and warning signs. Remote operation of the disconnecting means may also be considered, allowing workers to disconnect the load bank from a safe distance. To ensure compliance with all applicable codes and standards, it is essential to conduct a thorough assessment of the load bank installation. This assessment should consider the following factors. Firstly, the type of load bank, whether it is resistive or inductive, and its intended use. Secondly, the electrical characteristics of the load bank, including its voltage, current, and power factor. Thirdly, the location of the load bank and its proximity to other equipment and personnel. Fourthly, the potential electrical hazards associated with the load bank's operation and maintenance. Fifthly, the applicable requirements of the National Electrical Code, NFPA 70E, and local electrical codes. Based on this assessment, a qualified electrical engineer or electrician can determine the appropriate disconnecting means and its location. The disconnecting means should be selected and installed in accordance with all applicable codes and standards, and it should be properly labeled and maintained. Regular inspections of the disconnecting means are essential to ensure its continued functionality and safety. These inspections should include checking the condition of the fuse block, verifying the fuse ratings, and ensuring that the labeling is legible. Any damaged or worn component should be replaced promptly. It is important to note that the information provided here is for general guidance only and should not be considered a substitute for professional engineering or electrical advice. Electrical codes and standards are complex and subject to change, so it is essential to consult with qualified professionals to ensure compliance and safety. In summary, while the National Electrical Code does not explicitly require disconnecting means for all resistive and inductive load bank installations, a disconnecting means may be necessary based on other codes, standards, or specific site conditions. A fuse block can be used as a disconnecting means if it meets certain criteria, including being rated for the full load current, installed in a readily accessible location, and labeled as a disconnecting means. The distance between the disconnecting means and the load bank should be minimized to reduce the risk of electrical hazards. A thorough assessment of the load bank installation is essential to determine the appropriate disconnecting means and ensure compliance with all applicable codes and standards. Remember to consult with qualified professionals to ensure the safe and compliant installation of electrical equipment and systems. Electrical safety is paramount, and it is crucial to follow all applicable codes and standards to protect workers and prevent electrical hazards. Always prioritize safety and seek professional guidance when working with electrical equipment and systems. The proper application and maintenance of disconnecting means play a vital role in ensuring electrical safety in the workplace. Let's now explore some practical examples and scenarios to illustrate the application of these principles. Consider a scenario where a large resistive load bank is used to test the capacity of a backup generator in a data center. The load bank is located in a separate room adjacent to the generator room. In this case, the National Electrical Code may not explicitly require a disconnecting means for the load bank itself. However, NFPA 70E would likely require a disconnecting means to protect workers who may need to perform maintenance or troubleshooting on the load bank. A disconnecting means should be readily accessible and clearly labeled, allowing workers to quickly de-energize the load bank in case of an emergency. A fuse block that meets the previously mentioned criteria could be used as the disconnecting means. Alternatively, a circuit breaker located in the electrical panel that feeds the load bank could also serve as the disconnecting means. The choice of disconnecting means would depend on factors such as the load bank's current rating, the available space, and the preferences of the electrical designer. Now, consider another scenario where an inductive load bank is used to simulate the load of a large motor in an industrial plant. The load bank is located on the factory floor, near the motor control center. In this case, the National Electrical Code may not explicitly require disconnecting means for the load bank. However, local electrical codes may have specific requirements for disconnecting means for equipment located on the factory floor. These local codes may require disconnecting means to be located within sight of the equipment or within a certain distance to ensure worker safety. The disconnecting means should be readily accessible and clearly labeled, allowing workers to quickly energize the load bank in case of an emergency. A fuse disconnect switch could be used as the disconnecting means in this case. A fuse disconnect switch combines the functions of a fuse block and a disconnect switch in a single enclosure. This provides both overcurrent protection and a readily accessible disconnecting means. The fuse disconnect switch should be rated for the full load current of the load bank and should be installed in accordance with all applicable codes and standards. In both of these scenarios, it is crucial to conduct a thorough risk assessment to identify potential electrical hazards and determine the appropriate safety measures. The risk assessment should consider factors such as the voltage and current levels, the potential for arc flash, and the proximity of workers to energized equipment. Based on the risk assessment, additional safety measures may be necessary, such as the use of personal protective equipment, the implementation of lockout-tagout procedures, and the provision of training for workers. Remember, electrical safety is a shared responsibility, and everyone involved in the operation and maintenance of electrical equipment should be aware of the potential hazards and the appropriate safety precautions. Now let's delve into the specific requirements of the National Electrical Code that may indirectly apply to load bank installations. While the NEC does not have a dedicated article specifically addressing load banks, several articles contain provisions that may be relevant. Article 110, Requirements for Electrical Installations, provides general requirements for electrical installations, including requirements for disconnecting means. Section 110.22, Identification of disconnecting means, requires that each disconnecting means be legibly marked to indicate its purpose, unless located and arranged so the purpose is evident. This requirement applies to all disconnecting means, including those used for load banks. Article 225, Outside branch circuits and feeders, covers the installation of electrical circuits that extend outside of buildings. If a load bank is located outside of a building, the requirements of Article 225 would apply. Section 225.32, Disconnecting means, requires that a disconnecting means be provided for each building or structure supplied by a feeder or branch circuit. This disconnecting means must be readily accessible and located either inside or outside the building or structure. Article 408, Switchboards and panel boards, covers the installation of switchboards and panel boards, which are commonly used to distribute electrical power to various loads. If a load bank is connected to a switchboard or panel board, the requirements of Article 408 would apply. Section 408.55, Overcurrent protection, requires that each circuit be protected against overcurrent by a fuse or circuit breaker. This overcurrent protection must be sized appropriately for the load and the conductor ampacity. Article 430, Motors, motor circuits, and controllers covers the installation of motors and motor circuits. If a load bank is used to simulate the load of a motor, the requirements of Article 430 may apply. Section 430.102 location requires that a disconnecting means be provided within sight from the motor location and all control locations. This disconnecting means must be capable of disconnecting the motor and all control equipment from the power supply. Article 600, electric signs and outline lighting, covers the installation of electric signs and outline lighting. If a load bank is used to test the power supply for an electric sign, the requirements of Article 600 may apply. Section 600.6, disconnecting means, requires that each sign be provided with a disconnecting means that is readily accessible and within sight of the sign. These are just a few examples of the National Electrical Code articles that may be relevant to load bank installations. It is important to carefully review the NEC and other applicable codes and standards to ensure compliance. In addition to the National Electrical Code, other industry standards may also provide guidance on load bank installations. IEE 1584, Guide for Performing Arc Flash Hazard Calculations, provides guidance on performing arc flash hazard calculations. Arc flash is a dangerous electrical phenomenon that can occur when a short circuit creates a high-energy electrical arc. Load banks can pose an arc flash hazard, so it is important to perform an arc flash hazard calculation to determine the appropriate level of personal protective equipment for workers. NETA, the International Electrical Testing Association, provides standards for electrical testing. NETA standards can be used to test the performance of load banks and ensure that they are operating within the specified parameters. These tests can help to identify potential problems before they lead to equipment failure or safety hazards. It is also essential to consider the manufacturer's recommendations for load bank installation and operation. Load bank manufacturers typically provide detailed instructions on how to install, operate, and maintain their equipment. These instructions should be followed carefully to ensure safe and reliable operation. Regular maintenance is crucial for ensuring the continued performance and safety of load banks. Maintenance tasks may include cleaning the load bank, inspecting the resistors or inductors, and testing the control circuitry. Any damaged or worn components should be replaced promptly. By following these guidelines and consulting with qualified professionals, you can ensure the safe and compliant installation and operation of load banks. Electrical safety should always be a top priority, and it is essential to take all necessary precautions to protect workers and prevent electrical hazards. Always remember that working with electricity can be dangerous, and it is crucial to have the necessary training and experience to perform electrical work safely. If you are not qualified to perform electrical work, always hire a licensed electrician. In conclusion, the decision of whether or not to install a disconnecting means for a load bank depends on a variety of factors, including the type of load bank, the location of the load bank, the applicable codes and standards, and the potential electrical hazards. A thorough assessment should be conducted to determine the appropriate disconnecting means and ensure compliance with all applicable requirements. Electrical safety should always be a top priority, and it is essential to take all necessary precautions to protect workers and prevent electrical hazards. Consulting with qualified professionals is essential to ensure the safe and compliant installation and operation of load banks. By following these guidelines, you can ensure that your load bank installation is safe, reliable, and compliant with all applicable codes and standards.